So here we are, algebra guys. I'm going to make this recording for studying for the final. Here's the first question that you get on the final. It's a real simple question. It just says, hey, guys, can you simplify? So it says, simplify this. It says, hey, what if I have, let's say, 3x squared, and we'll cube that, and then we'll multiply that next one by 4x to the fifth. And it says simplify this whole thing. And I don't want you to freak out or anything. We're going to use order of operations, so we're going to have to, unfortunately, worry about this exponent out here outside the parentheses first. So we're going to go ahead and we're going to evaluate this exponent out here. And all that means really is, I guess I can draw it in another color. It just means 3x squared times 3x squared times 3x squared. Well, instead of writing all that crap out, let's just go ahead and cube the 3 and then cube the x squared, right? And we can count them up as we go, but you don't have to write this out on the test. So we have 3 iterations of 3x squared. So 3 times 3 times 3, of course, is 27. And then x squared times x squared times x squared is x to the sixth. And if you remember your powers and your product of powers and your powers of powers, if you have the 3 outside parentheses, you go ahead and multiply these two powers, and that's where we get our 6. But it's really just this. Then what we're going to do is we're going to multiply this 27 x to the sixth by that 4 x to the fifth. And this is simple product of powers here, and then 4 times 27. Now 4 times 27, that's 80, that's 108. And then x to the sixth times x to the fifth is x to the 11. And there we are. That's that first whole problem there. It will take you a lot less time than I just took just now, but hey, I want to make sure that you get off to a good start there. So we move on to the next one, and it says, hey, what is the y-intercept and the axis of symmetry of the following function? And then they give you a function. And I'm going to write out a function. What's the AOS? And what's the y-intercept? And you'll remember we talked in class, the y-intercept is always what I call the constant. So I'll put that up here. That's that thing that doesn't have a variable next to it, doesn't have an x next to it. It's hanging off the back end. It's usually our whole number added or subtracted at the end. And our axis of symmetry, we'll remember that formula is negative b over 2a. I think I give it to you later on in the test. You can have that written down somewhere. I said I would allow you guys to have notes or a note page. So let's go ahead and let me give you some sort of function. And a function just means y equals, but here's the function I'm going to give you. I'm going to say f of x, some function of x, some output, when we put some sort of x in there. And I guess I'll say 5x squared minus 8x. Oof, that's a horrible one. don't do that. Let's say minus 10x plus 6. Right, so now we have our function given to us, and we're going to be able to pick things out right away. The first thing you're going to be able to pick out is your y-intercept. And your y-intercept is right here. It's that constant. So the answer to that is just going to be 6. It's going to have that listed, and then it's going to have a comma. And what do we have to do next? Well, we have to do a little bit of math. Negative b, we see b here is negative 10. Well, negative 10 ends up being positive 10 over 2 times a, and a happens to be 5 here. And so 10 over 10 is equal to 1. Right? So 6 is our y-intercept, and we would say that our axis of symmetry x equals 1. Because at the x-axis, that's right down the center of our axis of symmetry, that's 1. Got it? So I'm going to move on to the next problem, I guess I'll call it. It's not really a problem. Just another concept for us, isn't it? It's not a big deal. So it says simplify, and it gives you a simple idea of binomial. Let's simplify. God, I could leave this up here for half the problems to simplify. It says simplify, and then we get a binomial. We get a binomial, 2x minus 4. Then we're going to add to it negative 4x plus 8. And really all we do here is add like terms, so 2x plus negative 4x is negative 2x. And then negative 4 plus positive 8 would be positive 4. Got it? So I'll get rid of that one. There's another simplify problem coming up, so I'll leave the word simplify there. I'm going to cut off a bit of it, but we won't be too upset. There we go. Then it's just a simple distribution problem. So let's go ahead and distribute this one. I'll give you, let's say, 4x on the outside, and then 6x squared minus 8 on the inside. And all we're going to do, well, I'll say 8y. Ooh, I'm really going to mess things up. All we're really going to do is distribute this 4x here and here. So 4 times 6 is 24. X times x squared is just x cubed. And we're going to have the subtraction symbol there. 4 times 8 is 32. And x times y is just x times y. And we're done. That's it. That's all your simplification that you need. The next one I'll get to a little bit later when we start talking about synthetic division. Actually, I can talk about synthetic division now. Let's go ahead and do that right now. It says simplify, but you can use synthetic division to do it. So let's go ahead, because you guys were pretty good with the synthetic division. So it is just a piece of division, and it looks something like this. Let's do this. Let's do x squared Plus 11x plus 24. Right? This is a real easy one. You could actually factor this, but I don't want you to factor it yet. It says divide this by x plus 3. And what I want you to do, since you're used to it, is go ahead and set this up as some sort of synthetic division problem. And here we go. Synthetic division, obviously, is super simple. We're going to put a line here. And on that line, we're going to put the opposite of our divisor, our root, as it were, of 3. And I'm going to change that color so I don't have colors blending when I do this. Get back to beautiful pink. And make our big long box. And now I'll start putting numbers in a different color. I'll talk about our coefficients. Well, our first coefficient here is a 1. Our next coefficient is 11. And our constant back here is 24. And we can use this to divide. It's going to be actually very, very easy when we do this. We're going to bring this 1 straight down. We're then going to multiply 3 times 1. And we're going to get, what did I forget? What did Sokol forget? We want to put the root up here. It's got to be negative. I was looking at it, it didn't look right to me. So 1 times negative 3, well, that's better. 1 times negative 3 is negative 3. We put it here. Now we do a little addition. There's our 8. There's where the 8 comes from. Negative 3 times 8 is negative 24. That's going to add up to 0. This is our remainder over here. And this is our new binomial. And what this really says is, and our final answer is, it's x plus 8. So when you divide this quadratic by x plus 3, what you get out is x plus 8. Perfect. Those were our two factors, right? And if you foiled this with this, you would get that. And that's exactly what it looks like. Sorry about that negative there in the beginning. At least I caught it. Guess my humanity is showing. All right, moving on. There is a problem with some synthetic division that you look at it and you have to choose one of the 4 answers that shows the right way to solve it, and you're going to see it really, really, really quickly. The next problem that's on there is not a simplify problem, so I'm actually going to have to get rid of simplify. The next problem that's on there is a factoring problem, and this is where I really want to spend the time in this video. I want to talk about factoring. It's playing that detective game. It's factoring polynomials really completely. I'm going to go back to, I'll call it m squared plus 11m. And this is what I just used last time, because I want you to be able to look at it and understand why we can do this a number of different ways. When we factor a quadratic like this, most likely what we're going to end up with is 2 binomials, an m and some sort of whole number, and an m and plus or minus some sort of whole number. So the first thing we do is we look at this symbol here. We want to make sure you know what this is. Like I've said a million times before, if that's addition, then both of these have to be the same. Both the addition or subtraction symbols have to be the same. My next step, if they're both the same, is to look right here, and we see that they're both going to be addition. So we've solved quite a bit of our work right there, because now we know it's m times m and plus and plus. Okay, now we need to find factors, numbers that multiply up to 24, but those same factors add up to 11. So if we start thinking about factors of 24, what do we multiply to get to 24? Well, it's 24 times 1, 12 times 2, 8 times 3, 6 times 4. We're done, and we see that 8 plus 3 gives me 11. 6 plus 4 only gives me 10. 12 plus 2 gives me 14, etc., etc. So we have to use 8 and 3. And I'm not just going to do this one only, but this is what we're looking for when we're factoring. I'm going to do another one just so you get a chance to see factorization with different types. Pardon me. You're going to see something that looks like this. B squared minus, let's say, I don't know, 49. And it's going to say factor this. And you're going to say, sir, come on. What is that? Well, or you could also have an equation that says b squared minus 49 equals 0. Well, you can solve this too. So we can almost solve them the same way. The idea is the same. Look, this is a perfect square, and this is a perfect square. For my taste here, I love this, and we know what this is called, and I'm going to write it here. This is a difference of squares, right? Remember what we called this earlier on? Sorry. It's a cool term, and I'm going to keep using it. So as you go on in math, we keep using this idea of difference of squares, and all that means is that it's perfect square on this side, perfect square on this side with subtraction in the middle. How do we get there? Well, I'm going to factor this and show you how we got there. To get a negative before your constant, you have to have addition and subtraction. There's no other way to get it. To get b squared, it had to be b times b. I mean, everybody knows that. And last but certainly not least, the only way to get 49 when you multiply something times itself is 7 and 7. And if I foiled this, which is what we're going to do last, if I foil this, you would see that my middle terms, 7b and negative 7b, would cancel each other out. And I promise I'll show you that. This is basically the same idea as this, but then solving each of them for 0. But we can do this an easier way when we solve this quadratic equation. We can show the solutions of positive and negative 7 just by solving this equation by doing a little bit of easy algebra. We're going to add the 49 to both sides to isolate my b, right? So we'll add 49 here. Well, then I'll have b squared equals 49. Well, how do I undo a square? Well, Sokol says, let's take the square root. Take the square root. We'll take the square root. And the easy part of that is over, because all I have to do is say that the square root of b squared is b. There's a problem here. You know, I could have done it two different ways. I could have squared positive 7 or negative 7. And there we are. So we have to show that plus or minus. That's later on when we're solving quadratic equations, which is later on in this test. So I've done a whole lot for you with this one problem, this difference of squares problem. I'm going to move on and I'm going to do a little bit more of this just so we can get used to factoring. There are two more factoring pieces that I want to show you. There's obviously that same idea of, let's call it y squared minus, let's see, 2y. Minus 48. Oh, good grief. What are you doing to us, Sokol? I can hear you guys saying it right now. It's not that hard. All right, so you see a subtraction symbol here. This is the first thing you look at, remember? So you look here and you see it's subtraction. Well, the only way to get a negative out of this, to get subtraction out of this, is to have one of each sign, right? Because a positive value times a negative value gives me a negative value of subtraction. We know that y times y is y squared. So the only real detective work we have to do in this situation is find factors of 48 or factors of negative 48 that have a sum of negative 2, right? So there could be a few of them, right? So we want the 2 to be bigger, you know, we have our negative to be a little bit larger. So is it negative 48 and 1? Absolutely not. That's garbage. Is it negative 24 and 2? Nah. We ain't got it there. Is it, let's see, negative 16 times 3. Negative 16 times 3. I think that's 48, isn't it? Yeah, 18 and 30, yeah. 48, and no. Is it negative 12 and 4? No, we're getting closer, obviously, but, you know, we're still at negative 8 here, right? And so, no, that doesn't work. So the last one we're going to try, and that's why I use this set of numbers. Negative 8 times positive 6 is negative 48, and negative 8 plus positive 6 is negative 2. So the 8 has to go next to the subtraction sign, because that's the negative part, and the 6 has to go next to the addition sign, because that's positive. So there you are. Not a huge deal, right? Not a very difficult concept to get. The very last thing I want you to think about when we're doing this is, I'll give you one more, z squared, and I'll just say, oh, what the heck, minus, I don't know, let's say 9z, and then I'll say plus 20. Right? That's the only thing we haven't had, right? Is a negative here and a positive here. We've had negative, negative. We've had positive, positive. Now we're going to have negative, positive. I could have had a positive and a negative. You'll get over it. But I want the signs the same with a negative that just shows you that we look here first, it's positive, they have to be the same. If they have to be the same, then they both have to be negative, or they both have to be subtraction. I hope you understand that every time I use the word negative and subtraction, their meaning is basically the same. So z times z gives me z squared. And then now I'm going to look for factors of 20 that add up to negative 9. They're both going to be negatives. So factors of 20 that add up to 9. You already know it, I'm sure. I'm going to write them down. 20 and 1, no, they don't add up to 9. 10 and 2, nope, not 3, but 5 and 4. 5 and 4 add up to 9, you bet. Negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9. And that's really all there is with factoring. I'm scrolling right now on the test itself to make sure I haven't put anything crazy on there. Solving quadratic equations by factoring. And I sort of did that. I have some square roots right there that I'm looking at. So I'm going to solve one by factoring. And then I'm going to move on and do a little bit of AOS work. Other than that, I think we're going to be okay. So let me get right back to solving by factoring, and then we can look at one or two more things. Let me get rid of that. Sorry, I was looking through the test. So here we go. Let me give you something simple to do. Shoot. Let's do x squared minus 6x, I don't know, plus 8 equals 0. Let's use some easy numbers here. Solve this. Give me the roots of this quadratic equation. What are the two values of x? Right, because we have two x's there. It's x squared. What are the two values of x that are going to make this sucker equal 0? And here we go. We're going to factor this just like we factored before and then solve both binomials for 0. So let's go ahead and factor. I want two sets of parentheses. And since there's addition here, this is the first thing we look at. Both signs in here have to be the same. Then if they're both the same, they both have to be subtraction or negative. All right. Well, we know the x part. We got that part down pretty darn good. Now, factors of 8 that add up to 6. I could go through this whole thing, but this is a super long video already, so there you are. Now, we have to solve both of these, make them both equal to 0, so x minus 4 equals 0, and x minus 2 equals 0, and then solve it. Please, God, please, this is the last time I'm going to do this. You should know this by now. You're at the end of Algebra 2. If you don't know how to do this part right here and find that x equals 2 and that x equals 4, there's no reason for you to move on to the next level if you can't do this. By the way, it's plus 4 and plus 4. All right, so there it is. That's solving quadratics. There was the other way, right? There was having the difference of squares, and I showed you that earlier. I'll show you one more. What if it says x squared minus 81 equals 0? Remember, we factor this. We know this is a perfect square. We know this is a perfect square. So it's got to be a difference of squares. We could say that it's x plus 9, x minus 9, and solve it this way. We could say x is plus or minus 9, because that's what you get. You get positive 9 to make this one 0. You get negative 9 to make this set of parentheses 0. Either way, we win. Or you can solve it like we did before. X squared minus 81 equals 0. Add 81 to both sides. X squared equals 81. Take the square root. Take the square root. And then x is going to be equal to plus or minus 9. So there are two ways to skin this cat. And you'll be good to go. I think the last thing, thank goodness it's been a very long video, hasn't it? It should be a long video. It's a final exam, for goodness sake. So the very last thing I want to go ahead and put on here is looking at a graph, finding AOS, right? Let's find our AOS by looking at a graph. I don't have a graph handy, so I'm going to go ahead and rough one real quick. Where'd you go? There it is. Let's put that there. Woo! That is fat. That's disgusting. All right, let's get rid of it. Let's get rid of this. Sorry about that. I wasn't set up for it, so I'll rough a graph. I apologize for my graph. Let's go ahead and do this. It's my x and my y axis. I'm going to just do a rough sketch of a parabola. Let's make it really bright. So there's a parabola. Goes that way. And what I'm looking for is this center line right here. That's my AOS, right? My axis of symmetry. Right? So when you're looking at a graph, you can find your AOS. You can see, what is that x value right there? That's my AOS. Well, that AOS also tells me something else. It tells me my, It tells me my x value of my vertex. I'm going to write this way out here, vertex. And you're going to be able to see these things on the graph. The vertex is right there. But of the vertex, this x coordinate is my AOS. The only reason I'm going over this again, because I don't know how many times we've talked about this in class. It's just silly, right? And then I'll close this over here. What's this y value over here? What is that equal to? Well, that's my max or min. My max. There we go. My max min. My max or my min. Well, it's going to be a min here, isn't it? It's going to be a min here because it's pointing upward. That's a minimum value of this whole function. All right, so my AOS, if I'm looking at a graph, I just see where it crosses the x-axis, right? And if I want to know what the y value of my vertex is, I just look and see where it exists along the y-axis. And say, okay, well, that's my min. Y equals whatever. Okay, so that's the idea of looking at graphs to get this done. Now, what happens if I've got an actual function that I'm looking at? Well, then I'm going to have a little bit of trouble. Then I'm going to have to do a little bit of work. So let's go ahead and talk about the last part, which is taking an actual function. We'll say y equals, and I'll use something that let's say x squared, I don't know, plus 6x plus 8, I guess. Darn it. Yeah, that'll be good. Here we go. And so what do we have to do? Well, we have to find the AOS. Our first step is find that AOS. Remember, the AOS is negative b, so that's negative 6, divided by 2 times a, which is 1. So let me go ahead and put those numbers in. Negative 6, because that's b right there, divided by 2 times 1, because there's only one x squared term there, 2 times 1. So our AOS is negative 3. So if we were going to graph it while we were working at it, we'd say we'd go backward, use that, 1, 2, 3 steps, and here's where the center of that parabola would be. And then we could say, we would know that way up here at 8, that's where it's going to come through, and that's what 3 steps away, so 3 steps that way and up 8. This is me just roughing the graph. Sorry, it should be over here. I wasn't looking. Should be right about there. Make a good parabola. So our next step, we're going to get our vertex eventually, right? We eventually want our vertex. So let's see the vertex. Well, we have our x value, that's negative 3. I'll change colors for you. Negative 3. And then comment. Now, how do we find out what this max or min is? Well, you take this negative 3 and you input it for x, and that'll give you your answer. So the funny thing is, I'll just put this in here, and I'll say negative 3 squared plus 6 times negative 3 plus 8. Well, negative 3 squared is 9. 9 plus 8 is 17. Minus 18 gives me negative 1. Sorry, I had to go downstairs there. So my pink number is going to be negative 1. If I find that there are other things that I have on the test that I haven't talked about, I'll get to it in class. But guys, this is it. That was the entire test, except for a lot of foiling. If you'd like, go to my YouTube channel, or maybe I'll post foil. Everybody knows how to foil. If you have any questions or you want me to make a video that adds in the foil plus anything else I might have missed, please let me know. But that's the test. Foil is just backward factor. You guys are going to do great. Thank you for your time. I'm sorry it took so long, but there's a lot on this test. Take care, guys. Bye-bye.